Assalamu alaikum. Hello viewers. Today I will discuss with you some problems from series. Here are types of problems. I will show you here. First of all, here I have shown you some formulas from this series. Three types of problems are from one type is binomial expression, another is geometrical series, and arithmetic series. So in a binomial expansion, I have another lecture of O level in my YouTube channel named binomial expression. There you can see the explanation of the formula, derivation of the algebraic formula, and um, any specific term. Here I just mention the formula in one glance. Binomial coefficients denoted by NCR or N and R can be found using Pascal triangle, and the formula is NR, where n factorial divided by r factorial times n minus r factorial. Here what is n factorial? N factorial is the formula is, if we suppose the value of n is 3, then 3 factorial will be 3 times 2 times 1. So n factorial means n into n times n minus 1, n minus 2, n minus r plus 1. So and for another formula is 1 plus x to the power n, n the value of n n0, n0 it means nc0, n1 means nc1. Okay, so you have to find the combination from of nc2, where c means combination, where the r plus 1 term will be in r and x to the power r. Here similarly for this, for a plus b to the power n, r plus 1 term is n r, and a to the power n minus r, b to the power r. Derivation of this expression, how this r plus 1 term came, you have to see my binomial expression lecture in my YouTube channel. You will get the explanation from that lecture. And similarly another formula is 1 plus x to the power n, 1 plus nx plus n into n minus 1 by 2 factorial x square, n into n times n minus 1 n minus 2 by 3 factorial x cube, and then x to the power n. For arithmetic series, we can find the kth term by this formula, and the last term will be a plus n minus 1 into d, and sum of the terms will be n by 2 times 2a plus n minus 1 times d. For geometric series, the kth term is ar to the power k minus 1, the last term will be ar to the power n minus 1, and sum of the terms will be a times r to the power n minus 1 divided by r minus 1. And infinite series to converge, some condition for the infinite series to converge is minus 1 to 1, where s of infinity will be a by a divided by 1 minus r. Now going to show you some solved problems. Here problem 1. The first term of a progression is 4x and the second term is x square. For the case where the progression is arithmetic with a common difference of 12, we find the possible values of x and the corresponding values of the third term. For the case where the line progression is geometric with a sum to infinity of 8, we have to find the third term. Here first term is 4x and the second term is x square, we are given, and the common difference is 12. So we can write that difference of second term and first term is x square minus 4x is equal to 12. From that we get the value of x is 6 and minus 2, and from the values of x we can find the third term. When the value is 6, value of x is 6, the third term will be second term plus common difference, so third term is 48. And now if x is equal to minus 2, second term will be, third term will be 16. So possible values of third terms are 48 and 16. Now geometric progression, for the first term here is 4x, and second term ar is x square. So we can divide, by dividing we get ar by divided by a, and as usual, on the right hand side, x square divided by 4x, so value of r will be x by 4. So as up to infinity is equal to a by divided by 1 minus r, so value of x by calculation and doing side change, we get the value of x is 4 by 3, and value of r will be 1 by 3, so the third term will be r square, that means 16 by 27. This is our geometric progression. Now another problem, we are given the third term and fourth terms of a geometric progressions are 1 by 3 and 2 by 9. We have to find the sum to infinity of the progression. Here a circle is divided into 5 sectors in such a way that the angles of the sectors are in arithmetic progression, and given that the angle of the tangent largest sector is 4 times the angle of the smallest sector, we have to find the angle of the largest sector. So we are given the third term ar square is equal to 1 by 3, and fourth term ar to cube 2 by 9. So by dividing ar cube by ar square, we get the value of r, which is 2 by 3. Now for finding the first term, why do we need first term? Because if we don't get the value of a, we can find the sum to infinity. So by using the value of r, we get the value of a, which is 3 by 4. Now sum to infinity is, formula is, we know that sum to infinity is a divided by 1 minus r. Substituting by value of the r, we get the sum to infinity is 2 and 1 by 4. Now another part, for n equal to 5, fifth term, we know for we are given that 4 times first term, because here in the second part of the problem we are given in our question that the angle of the largest sector is 4 times the angle of the smallest sector. So fifth term, that means largest sector will be 4 times of the first term. So if the first term is a and the fifth term is 4a, then s5 last term will be 360, because we are we can because the circle, whole circle, if we the whole angle will be 360, right? So sum of all angles will be 360. That means we can here but we know the formula is n by 2 times a plus l, first term and last term, divided by 2, and times number of terms. Then by using this formula we get the value of a, which is 28.8, and by this the value of a we get the largest angle, which is 115.2. Now problem 3, in the expansion of this, we have to find the coefficient of x, where the coefficient of x square is 0. We have to find the value of a. Here if we expand this binomial by binomial expansion, we get first 6 0 and 5 to the power 6, 6 to the power 0. Listen here, if you see the value of lower term will increase, and the value of the highest term, first term, upper term, will decrease. That means when here comes 1, the power of 5 will decrease and the power of x will increase gradually. Okay, that means you can easily remember this 6 is 0, 5 to the power 6, and here x to the power 0, that means value of will be 1, and similarly 6c1, here 5 to the power 6 minus 1, and x to the power 1. So power of 5 is decreasing and power of 5 is increasing. Here you can remember by this way through easily. And now first we get the expansion, and then we multiply this expansion by first term 1 minus x by a, then we get our coefficient of x square, and which is from that we get the value of a, which is 2. And another problem, here we have to find the term independent of x in the expansion of 3x minus 2 by 5x to the power 6. We can expand it like before. first term, second term, here 60, that means 6 is 0, 6 to the power 6, that, and second term to the power 0, that means in power of first term decreases and power of first term increases. And the last term is that means when the value power of x, we can cancel here. If we see, notice this term here, we can cancel the power of x term, right? Here it will become x cube, and here also here we found x cube, and this x term will cancel, and so that this term will become without x it becomes minus 864 divided by 25. We can do this problem through another way, another method. We can solve this problem too. Now another method here, if we see, another method is if we let the r plus 1 term is independent of x, so the r plus 1 term is 6cr, first term to the power 6 minus r, and second term to the power r. Now here 6cr and 3 to the power 6 minus r, x to the power 66 minus r, second term minus 2 by 5 to the power r, and x to the power 1 by x to the power r. So x to the power 6 minus r, so it becomes 6 minus 2r. From 6 minus 2r we get the value of r is 3. So by using the value of r3 we get the 3 plus 1 term, which is minus 864 divided by 25. This is our r plus 1 term. So I hope these problems I discussed here will help you to understand that topic more clearly, and please subscribe my YouTube channel and help me. It will inspire me to serve you more and make mathematics learning easy for you. Thank you everyone.